Well, hi, and welcome to my shop here. It's November 8th, and this is my second day on this radio. I think so, yeah. So, yesterday, I think maybe this is my third day. Yesterday I tested the tubes. They all came out pretty good, including the rectifier tube, output tube. Even the magic eye has a bit of glow in it. So that's quite good, but the one thing I did discover during that is the radio has been altered to accept an alternate tube in one position, and that's up here. So the normal tube in here has a grid cap on it, and that's gone. And the only way you can make an alternate tube without a grid cap work in here is to alter the wiring underneath on the chassis. I'm pretty sure of that. I can't imagine you can just pop any old tube in there. My preliminary look into this yesterday was that the pin-out arrangement on this tube is different from the original tube. So conceivably somebody had to do something under the chassis to make this work with a different tube. And why a different tube? Because this is a newer, more modern vacuum tube, probably cheaper, and even back in the day, the original one might have been a little bit scarce. So probably not too tough to rewire this a little bit for that tube. Might want to explore that situation on the schematic. Now, unfortunately, the only schematics I found are poor quality reproductions, but I think they're good enough to get through the first step, which is just kind of a general understanding of the radio and its layout and things like that. We can look a little closer at the arrangement for that particular tube also for what it's worth. So let's look at the schematic here. Okay, so I've got this from Radio Museum, and I'm a member of Radio Museum. And here is the schematic. Here's some more information. This is looking from the top. This must be, bottom view of chassis. This is looking underneath. This is very helpful information here. Oh, voltage is all written in here, even though a little hard to read. Excellent information here. Here's that gigantic resistor down the side. Great. This is the back apron folded forward so you can see it. There's the adjustments. Fuse. Yeah, that's something we need to look at. We need to look at the fuse arrangement. Now what's down here? So they've done sort of a close-up of a particular area with a lot of information written into it. Oh, someone's at my door. AFC. AFC. Automatic frequency control. That's not the usual. Usually it's just a volume control. Unless this is a mistake, which I doubt it, frequency control. That's curious how they did that. Okay, so we might have to study this very carefully at some point. Oscillator grid. And is there a title? Detail of automatic frequency control. There you are. Automatic frequency control circuit. Now this is extremely unusual that a radio has something like this in it, of this vintage, and plus it's just an AM radio. It's not FM. FM's common to have some frequency lock going on, but very interesting. Well, I can't say I've ever encountered this kind of circuit, so this might take a lot of study to really understand it. But look at all the information they've given here. Fantastic. Okay, so we'll have to go through that at some point. Socket meter readings. Great information. Okay, back to the schematic here. I have a little piece thrown in here. Typical connections for low impedance pickup. Yikes, look at all that stuff. Pickup being, record player. Oh my gosh, look at what's going on with the speaker. I don't have the speaker here. Oh my gosh, look at all the stuff. First of all, it's 4 wires. So here's the field coil. Just hang on, Peanut. I'll let you out in a minute. Field coil. And then the other goes to the output transformer primary. look what's going on the secondary here. So this is going to the voice coil, which also has a hum coil. Hang on, Peanut. What is this? What is that? Okay. I'm going to go and deal with my kitty cat here, and then we'll get back to the schematic in a sec. Okay, my cat's happily outside now. Another beautiful, beautiful summer-like day here. Very, very odd. So let's go down through the schematic quickly this way, just through it. See if I can pick up anything interesting. So I have a whole series of antenna coils here. Don't seem to be padded or trimmed. Okay, and then the S1 antenna with a very odd arrow this way. This must be the movement of the switch. This must be depicting a switch of some sort here. Maybe this thing's moving along, connecting here. Okay, that's a weird looking switch here. Some kind of switch, probably almost certainly selecting the appropriate coil for the band you're on. Comes into a triode RF amplifier, comes out into this, transformed into these S2 RF. Have another arrow and a switching arrangement here. What is that? Appears to be 2 cigarettes on the schematic here. I don't know what these are. What are these? Okay, carrying on. Now we're getting into a mixer tube here. A little hard to see which grid is which. Bottom grid is this one. Back here. Down here. So the first grid is taking the signal from the antenna. Grid number 3. Different radios do this differently with how they use grid 1 and grid 3 in the mixer tube. In this case, the oscillator's on grid 3. There's some more of these suppositories that they have on here. Come down through here. Obviously this is some kind of selection for which coil you want for which band you're on to set the oscillator up. There's a separate oscillator tube here, 6J7. So it's a screen tube. 6J7. And then up here, where the mixing's occurring. Okay, that's great. After the mixing, the signal comes out, it's going to be at the IF frequency. Is there a hint on that, what the IF frequency is? Let me zoom in a little bit on this fuzzy guy. Let's see what we can see. No hint yet. Somewhere it'll say, though. Come through these capacitor-tuned IF transformer into another. This one's got a screen, 6K6, same as that. Out after a big boost, supposedly, into another complicated arrangement here. We have an IF transformer, comes out, I wish I could see a little clearer what's going on in there, because at a glance it almost looks like there's 2 plates, but one of them is probably the cathode. Can't really figure out the picture there. So this looks, it looks like there's another plate here. I don't know what's going on in that diagram. 6H6. Well, two diodes in here, that's all. So it is 2 plates. Probably 2 plates, maybe 1 cathode. So we have like basically a full wave rectification occurring right in here. So somewhere the output's getting across. This is the only wire. It must be coming across on here to get over to here. So we see some shielded wire here coming back from the grid of the 6F5, which this is the tube that's changed in the radio I have. Whoops. So they're showing the grid as a grid cap here. It's not a grid cap anymore. Volume control. Lots of capacitors here and resistors. I suspect it's to alter the tonal quality of the radio right through here. It's a masterpiece of engineering, if you ask the guys who designed this. I'm sure they would tell you that. Phono input. There's a little switch here. AFC switch. I think that's what that says. You turn the AFC on and off on this radio. Oh, that's right. There was this funny little switch on the front of this radio I was poking around with. And the switch was over-rotating. Well, that's got to be what this is. This got to be AFC. So you think about that for a minute. Why do they need an automatic frequency control? Why does a radio have to track around its tuned frequency? I think back in the day, there were transmitters that were wandering around a little bit. Another factor is as the radio heats up, it tends to drift a bit. So maybe this was compensation for that. I kind of doubt it. How it works, I don't know. It'd be interesting to read all that stuff. Not something that was continued. Maybe this is the first time I've seen just an AM radio with a frequency control. Okay, so let's continue on. There's the magic eye. 6G5. It's a 6E5 that's in the radio, though. I think they're direct replacements. So tone control here. I think. Should be another tone control somewhere in this schmozzle. Is probably another tone control. Maybe not though. We get to the output tube. Let's find the cathode. Looks like the cathode is solidly grounded here, which means the bias is coming from some kind of clever arrangement. So here's the bias right here, I imagine, coming in from, let's go see the cleverness, some resistor in the power supply. Oh, this would take a while to look at, I think. So this is probably the cleverness right here. And they're able to pick, what you do is you hook the chassis up to, not to the bottom of this string, but to somewhere in the middle. There it is right there. And what happens now is you claim this to be zero and everything relative to it. Positive, more positive, more positive. When you go the other way, it's negative. It's a sneaky way. Sort of cutting the chassis in part way through the voltage drop of the power supply in a sense, and you end up with this negative relative to the chassis. Let's follow it. Oh my gosh. Okay, let's follow this. I don't know if this is going to work out. And right up into here, right up into the bias area. So, there might be a voltage drop here of 5 or 10 volts, 15, whatever it takes. And then that is available up here. There shouldn't really be any current flow in these resistors of any significance, so the whole voltage should show up right here. So that's how the biasing is done on the output tube. 6L6. The output goes to the primary. That looks like another tone control right in here. this is a capacitor that's always across this winding. There's another one here. So whose purpose I still don't fully understand, although I'll bet you there's 100 comments on my videos about it, because every time I encounter it I make the same statement. People probably answering my question and I'm not reading their comment. If I come down here, this looks the same as the larger, the other part of the schematic. Voice coil, hum coil, secondary, and then what is this guy? What is he up to? Never seen this. You know, I could just imagine what it's doing. It's draining treble. It's because of the capacitor here. Well, why? I don't know. That's a big mystery there. Never seen that before. One of the things I like about this work is every radio I do becomes its own story. I've never had the same experience twice. I've done hundreds of radios and never had the same experience twice. I really like that. You never know what you're going to get into with these things, especially a big honker. And this is just before another technological change occurred in radios. And so, for instance, all these tubes here are three number letter designate tubes. Shortly after this period, I guess through the Second World War, and then in the production that came after the Second World War, these were all different. New technology swooped in. So this coil is the same as this coil. Okay, so I guess we made it all the way to the power supply. Sometimes we could start at the power supply. What's this over here? What's this guy? So that's the oscillator. They're not really connected. J7. Is this the frequency control circuit? Maybe that's what this is, because it's kind of out of the way on the schematic. It didn't draw it in the main flow of things. So the only way you could do that, this frequency control, is by manipulating the local oscillator frequency slightly, up and down. So you think this would somehow be tied to that. So you could look at the plate here. It's heading for the oscillators. Just this. So maybe what they've done is they've made the oscillating system sensitive to the effect of this tube through this transformer arrangement here. I don't know, it's all written up, so we don't have to guess at it too much. I'll read it in just a minute. Okay, so I think that's basically the radio. I didn't really go through the power supply here. Let's just do that. So what do we got happening here? We've got a couple different choices on the primary side. Secondary side, we've got heater supply for the rectifier, 5T4, and what do we got? 200 M total. 2 ohms? Is that ohms? Volts? I don't know. And then down here is the general heaters. Switch for the dial lamps. Yeah, this radio has a series of dial lamps, and as you switch band, it turns on different lamps to light up the dial differently. It's really quite cool. Okay, so out comes the rectified, full wave rectified. Got a pi type filter with this coil. And my understanding of this is the bulk of the filtering actually occurs in the coil. So these are usually relatively small. Looks like, I don't know, I'm guessing 14 and 20. Pretty big resistor coming off here. Okay, so well, this radio's got a lot of circuits in it, so it's going to have some funny business going on. almost certainly. Tap off at this level, a chassis connection here through a big resistor, or a resistor. I don't know how big it is. What's this all about? Because here's the main chassis, fixing this point as chassis 0. What's this doing? Just some kind. This is a voltage divider trying to arrange a number of voltages with an appropriate, I guess I could call it output impedance, to go do whatever it is it's going to do. What's it doing? What's it doing? Comes down. This one comes down here. Up here. Screen voltage here. This is probably all screen voltages. Screen supplies. Yeah, two screen grids in this tube. Yeah. So what they're doing is they're getting a screen voltage. It's not full B plus. And what is B plus in this radio? I don't know. Okay, let's go down to this very interesting part here. Try to read this as best I can. And they're numbered, number 1. When receiver is correctly tuned in, IF signal developed here is 460, and this voltage is applied across points A and B. Where did they write B? Where's B? Gotta be down here somewhere. Oh, those tricky people. They left the B off. Okay, so this is a really weird arrangement. Is B way over here somewhere? There it is! B. Wow, okay, so between A and B, across the diode and across the diode. So this 6H6 that's in the radio is there for this purpose only, for this AFC. It's not a regular diode. So this is just basically a, well, these are tipped. Yeah, I think it's a full wave rectification occurring here. Number 2, voltage. Oh boy. Oh, you know what? I'm not going to be able to read this. It's just going to drive everybody nuts if I sit here and try to read through this. See, I can read that. Let's read that. Grid control tube. Grid control tube is connected to a point. Grid of control tube is connected to a point on the oscillator tuned circuit, and the plate is connected to the high end of the oscillator tuned circuit. The phase relations are such that the amplified voltage developed on the plate has the same effect as an inductance in parallel with the tuned circuit. Okay, I'd have to read that about 5 times, I think, to really gather what they're getting at. But they're able to imitate an impedance, an inductance, using this technique they're using. This positive voltage decreases the bias on the control tube and increases the amplification. Did they mention remote cutoff here or somewhere? Grid of control tube. They're just calling it a control tube. This has the effect of increasing the equivalent inductance across the oscillator tuned circuit. So there it is. There it is. There it is right there. They figured out a way to make a tube appear like an inductance. Kind of like that. And then if they alter the function of the tube, they're altering this fake inductance, which then alters the tuning of the oscillator. Consequently lowers the oscillator frequency so as to correct the error in dial setting. So this isn't so much following a signal that's wandering around a bit, like a transmitter that's not stable. This is about how accurately you have to tune this radio. Get it close, and it'll kind of suck in and grab the frequency that you're tuning to. I think that's the story with this. I also think this is a spread band radio with multiple spread bands. I don't have to think, it's right here in front of me. Let me just peek at it again. They're all spread bands. So with a spread band, wow, do you really need all this? And it goes on and off, so we can turn it on and off and fiddle with it and see what it does. Maybe we could read this one. The circuit of L25, 26, and C33 is not in resonance with the induced voltage. This causes the voltage across the upper half of something, L25, to become more nearly in phase with the voltage applied across A and B, and increases the rectified voltage across R1. It also causes the voltage across the lower half of L75 to become further out of phase, and the voltage applied across A and B, and decreases the rectified voltage across R12. Consequently, the resultant voltage from C10 ground is positive. Well, look at how they've numbered these. So across the top here it's 1, 2, 3, 4, but along the bottom it's 1, 2, 3, 3 again. These are two different stories being told here. Fiddling around with the relative phasing of two signals, deriving a voltage from them that's then used to manipulate this tube, which is in the circuit in such a way that it looks like an inductor, sort of, to the oscillator. Wow, okay, so some engineers back there really burned the midnight oil on this. And then they would want to sell. This is a selling feature, of course. The only reason they put this on the radio is to try to sell more of them. There must have been trouble back then with people tuning radios and being frustrated about getting it right on. Now, in a band spread radio, that's not the case. It's easy to tune. But in a non-band spread radio, it can become really hairy, especially with a small little tuning knob in your hand. Really, really tricky to tune a radio. So this would be helpful in that case, but in band spread? Well, a little hard to understand all their thinking. So this is the actual oscillator control. Okay, well, I got a good idea of what it is. That's all I really need at this point. What we now want to do is find out what's going on with this tube. It's a 6F5 audio, this is right there, and in my radio, this radio, it's not my radio, 6, something else is in there. 6L5, wasn't it? 6J5, maybe it was. Okay, they do not have the pin numbers here. So they have the pin layout. I can figure out the number because they put the key right here. A little bit of trouble reading these. They're voltages. Oh, so here they put a letter in here indicating what each of these pins is doing, and this is what I'll be able to do to compare back. I think what I'll do is I'm going to make two sketches on paper. One will show the 6F5 like this, sort of pin out arrangement, and right beside it I'll draw a diagram of the other tube's pin out so we can see what the changes are and then look for those changes in the radio. Okay, here's the result. It's going to take a lot of thought in the end, I think. So original 6F5 and replacement 6J5. So the difference in these two tubes is just a couple things. One is, of course, this tube has a grid cap, and this tube has a grid hooked up to pin 5. You see pin 5 is doing nothing over here. So conceivably, the person who put this tube into the radio moved the grid connection to pin 5. That's easy. The next change that has to happen is the plate would have to change. On the original tube, the plate is on pin 4. On this tube, the plate is on pin 3. So make 2 wiring changes, and you can pop in this tube. Now, looking at the way they operate, first of all, can this tube take the plate voltage that this one's getting? So they both have the same rating. 250 would be a typical operation, 300 max, same thing over here. So in terms of blowing the tube up because of too much plate voltage, that's not going to happen. It's not terribly likely. Now, right away we start running into some very significant differences. So this tube in my tube manual is shown with a gain of 100, and this one is shown as a gain of 20. Exactly how that affects the radio and the way they're using this tube, I have no clue. But that's a significant difference between these two tubes. And this is the plate resistance. So this tube is looking for 7,000 ohms of plate resistance. This one's looking for 66,000. That's no small difference there either. So either somebody went in and made more changes to the radio to make this tube function properly, or perhaps in this particular case it doesn't matter. I mean, for all we know, there's a Westinghouse bulletin out there saying, hey, by the way, you can pop in one of these tubes and just make these changes, don't worry about anything else. Maybe. Go a little further. So the transconductance in this tube is 1500 as stated. In my tube manual, this one 2500, so that's different again. And the last one is the plate current in this tube when it's operating should be around 1 milliamp. That's quite low actually. And this tube wants to run with almost 10 milliamps. That's another factor of 10. So there's a factor of 10 between these things in a couple of areas. And the 6J5 is a very important tube in this radio. It's the audio amplifier following the detector heading to the output tube. So, I mean, if this guy's not behaving right, it's going to really show up. So we can't know at this point what all has been done in that radio without doing a lot more investigation and really laying out the component parts that are around these tubes, what I can see in the radio and what's on the schematic, and compare them. One thing I can do fairly quickly though is I can look for these two connections, which have got to be in there. There's got to be something on 5 and something on 3, and nothing on 4. Since I happen to have the radio sitting right here, let's take a look. See what we can see here. The place we're looking. Whoop, a little bit tangled up here. Looking right in here. So I want to try to pick off. Let's start with the grid. So the grid used to be a wire going up through a hole in this chassis somewhere. There's a hole. There it is, right there. Right there. There's something better to point with. Right there. So whatever went up there got removed and should have been stuck on pin number 5. Oh my gosh, now pin number 5. I gotta look at the top here. Okay, so there's the key. Looking that way, looking that way, looking that way. Key should be right in here. Chances are this is pin 1 right here. And I said pin 5. Oh my gosh, that's right down here. Yeah, so pin 1 looks like it's soldered to the chassis, which wouldn't be too surprising. Pin 1, maybe pin 2, maybe pin 3, maybe pin 4, maybe pin 5 with a green wire on it. So here we see the shielded wire going there. That makes perfect sense. So, I mean, unless somebody put that tube in there and this radio never worked again, something had to have been done here. So it looks like the pin 5 alteration of the grid wire was done. And then we look at pin 4, should be empty in here now. So that's pin 5, this is pin 4. It's totally busy. It's totally busy. Is it really pin 4? Pin 4 is a plate pin. So the plate wire should have been moved to 3. So we go to 3, presumably this is 3, and there's a jumper. So when you make the change, pin 4 goes open. There's no pin 4 in the 6J5 tube. So pin 4 becomes a connection point, and then you just jump it over to pin 3, and voila, plate voltage is then available for the tube. And what's going on in this pin doesn't matter because there's nothing in the tube hooked up to it. So it's a pretty straightforward change, and it's definitely there. It's definitely been done. Well, now you got to think, a guy who could do this kind of thing, he wouldn't do it. Like, he wouldn't do it on a whim. He'd already know ahead of time that the 6J5 is going to work. And why? Because it's probably a standard thing. And like I say, it could even be a service bulletin driven deal. For all I know. Okay, so that kind of raises the next. There's a couple more questions coming. The big question is, can I turn this guy on and see if it works? That's really where that's the end of the road question. Before I do any work on it, can I turn it on? The answer looks pretty good now. Like a yes. I turn it on with care. Okay. The next challenge, though, oh yeah, I gotta check out the fuse situation down here and figure out what's going on with this 3-in-1 fuse holder deal. Gee, I wonder if that's. I was gonna say, I wonder if that's a voltage change. You put the fuse here for one voltage, you put it here for another. That could be, you know. Yeah, that could be. That could be exactly what this is. This is how you change voltage. Let's take a look at the schematic because I missed that on it. Okay, so I want to look at the power supply. There it is right there. So you can see this says fuse, and there's 1, 2, 3. You fuse it one way for 120 volts, it looks like, and you fuse it the other for, I don't know what that is, 118? Yeah, that's no different. Does that say 150? Ah, it could be 150. Must be 120 and 110 or something like that. So you select where you want the fuse to go to control the voltage. And to accommodate the input voltage. And you use a 30 amp fuse. You use, is that it right there? What's that say? 0.2 amps, So the whole set is a 120 watt beast. So you got 100 watts with 100 volts coming in. You've got an amp. So this guy be drawing 1 amp. 1 amp at 120 volts is 120 watts. So I think there should be a 1 amp fuse, and more than a 1 amp fuse. Like if I put a 2 amp in there, I probably succeeded in protecting the radio, and it won't pop when I turn it on. Or is it listed in the parts list, or does it show up somewhere else, anywhere else? Fuse, wait, could write it right there, but they didn't. They refused to write it. Okay, but that solves that problem. Anyway, now I know what's going on. Or at least I think I know what's going on. So last thing is the speaker. So this radio's come to me without the speaker. It looks like the speaker has a lot of coils in it. Has the field coil, has a hum coil, has that other mysterious coil or secondary winding to nowhere. I don't know if I can do something. I've got a couple speakers here, but I just don't know if I can hook them up here. The field coil thing is a little questionable. I've got a speaker with a field coil, but what would happen if I plug that in there? Goodness knows. Goodness knows. Let me get it. So small speaker, great big ring around it. Now, you know, what are the chances you could just plug something like this right in and have it work? Almost nil. 4 wires. I mean, if it came from a Westinghouse, it's got the right number of wires. Goodness knows what all's going on in here. That's the field coil. So this is the appropriate type. It's got way too many terminals on there. Oh, look how they've just filled that with some kind of a compound, like a permanent compound. Well, it's got 1, 2, 3, 4, 5, 6, 7. I didn't count that right, did I? Yeah, I did. 7 with 2 fat ones. 7 with 2 fat. Start with that. 7 with 2 fat. Okay, so if we take a look at the plug, no, that's not 7. That's 5. Nobody's fat. That's 5. So we're definitely not gonna just shove this in there. Fat chance that could ever work anyway. So I'm going to have to do some funny business here. This may be a valid speaker, valid enough to make the set operate without a crisis occurring. I don't know. Okay, so I think I've done enough for today. Got lots of things to think about. I really do need to sort out the speaker situation because we need the field coil in the radio, and we really should have the correct field coil, not the field coil from some other speaker, but I don't have. Maybe I can convince the owner to get me the speaker, the real speaker. That might be a smart move rather than try something else. Hey, for all I know, the speaker's dysfunctional. I just had a old radio like this, exactly like this. In fact, it's sitting right there. This big one here. Output transformer shot on the speaker. I couldn't have found that out without the speaker. So I think I just convinced myself I've got to talk the owner into getting the speaker out of the cabinet. He didn't want to do it because it was awkward. I really think I need it. So thanks a lot for watching, and tomorrow I will pursue something more with this radio, speaker or not. See ya.